Hi everyone. Welcome to the Pandit Madan Mohan Malviya National Vision on Training Teachers. This is our series number two. This is on the 2022, February 21 to 28. We are on the day 6 of the event, and here we have Srinivas Adepalli, a what you call a expert in edge computing and various other things. So let me give you a brief intro to him, and then you will pass on the hand. So he's a software architect at Intel and specializes in cloud, edge, and IoT. And he's leading the strategy for software and architecture at Intel, focused on next generation technologies like edge computing, distributed architecture, orchestration, EVAN, distributed traffic and security controllers, and confidential computing. So he has a vast array of things to handle. He's also led previously advanced technology team at Freescale, which is not a x86, but that's good. So he has got a wider background and came out with a new products including ENB, that is Enode B, VPN controller, software, that is the serving gateway for 4G software platform. He performed product management and technology strategy and function for the software products related to new technologies and help identify, define accelerated technologies required in the SOCs. So he also has definitely depth in semiconductor. Now, before joining Freescale via acquisition of Intoto, he led the architecture development of next network security software for firewall, IPS, IDS, App ID, IPsec, and SSL VPN as CTO of and chief architect. So he has a very excellent background, and our faculty and research associate would learn a lot from him. And his topic is service orchestration for distributed edges, introduction to LFN and MCO projects. With that, I will hand over the floor to our honorary guest, Srinivas Adepalli. Go ahead, Srini. It is yours floor to go for whatever 45 to 50 to 1 hour, whatever you want to.
Okay. Yeah, thank you, Prakash. Today, my topic is about automation, right? Let me define what is distributed edge. Instead of definition, let me describe what it is. Today people are used to cloud computing, right? That is, workloads are placed in the cloud, like Amazon Cloud, Azure, GCP, and users access those applications, right? But increasingly, there are some new types of applications, right? They require very low latency access to the users, right? Whether it is Industry 4.0 kind of use cases, or even enterprise use cases where they want to provide best user experience, right? To provide best user experience, it is the best if you also move your compute, your applications closer to users, right? And that's where edge computing is started to becoming popular now, right? And whether it is tomorrow autonomous vehicle kind of a scenarios, immersive media type of scenarios, they all require low latency, real-time experience to the users, even though they are very far away from, let's say, a stadium, right, where the game is going on. The idea is that remote users also need to get the same experience as the users that are there in the stadium, right? Of course, it requires AR, VR kind of glasses, but more importantly, it requires that kind of experience means the compute has to happen locally, right? Locally in the sense that very near to the geographic population. And that's where edge computing is required. And since you have large number of users across multiple geographic locations, it just have to be many. That's where the term distributed edge comes into picture, right? So this presentation is about, when you have distributed edges, okay, how do one deploy these applications across multiple edge locations. That's one aspect of it. Some automation is required, especially if you have tens of thousands of edges, right? How do you deploy applications across them? That's one problem statement. Second problem statement is that how do I know which edges to choose the deploy application on? Right? So you need to have placement, kind of a mechanism to identify the right edge locations to place the workloads. Right? Sometimes it's way too expensive if you want to put your application across a large number of edges. You want to intelligently decide where to place your applications. Right? For all these things, simple scripting for deploying applications across multiple edges is not good enough. You require some intelligent system that actually allows you to define the placement constraints, right, and the placement policies, and let that system deploy your apps and do anything that is necessary to connect those apps together. That's where you require some kind of a orchestrator. That's what we are calling service orchestrator for distributed edges. So with that background, let me move to the next slide. Okay, this is the pictorial representation of what I just now said. Right, on the left side of the picture, that's what is cloud computing today. Right, there we are showcasing a cloud platform, could be AWS cloud platform, and an application consisting of multiple microservices. Here I showcased 4 microservices. Right, they are deployed in a cloud locations, maybe few cloud locations. Right, but now what we are saying is that there are some edge computing drivers as shown in the picture. One is latency. People want to get the low latency. That's the best user experience. And at times, second is the bandwidth, because nowadays, if you look at the video kind of surveillance or video recordings that are happening in the edge locations, or in the case of retail, a lot of video recording happen, right? And we want to analyze that video in real time, right, for analytics purposes, and that requires to be send this video all the way to cloud applications. That means you require a lot of bandwidth to send this video data to some cloud application for inferencing. You don't want to do that. You want to do inferencing locally. That is again one of the reasons why people would like to move the compute closer to the users instead of sending the data to the remote locations like cloud central locations. That's one reason. It's like economics at the end of the day. And the third reason is contextual, right? Sometimes if you look at this kind of advertisements, right? You don't want to have same advertisements, being played, in every country, right? So you want to have country-specific or region-specific ads to be inserted into, let's say, even in your video streaming, for example. That means you need to know the context, like where it is placed, okay, maybe which location, and based on that, it might play different advertisements. That's one example, right? There are a lot of other ways you can use the context to tune your application behavior. Sometimes, people talk about if you have a large number of bandwidth, right? You want to use lesser compression so that your video quality would be good. But if that your cell bandwidth, for example, is not so good, I mean, you want to put the some more compression, even if the loss is okay, right? So again, your applications have to get the context and then tune itself based on the context. That again, that requires that is done best if the compute is moved to compute edges. And there are other reasons like privacy, legal reasons, regulatory reasons. Sometimes people may not want to move the data to some other place, in which case the application needs to be brought to the data instead of data being sent to the cloud somewhere in central place. These are the 4 drivers actually. We believe that edge computing is becoming the reality and needed. So on the right side of the picture, that's what we are showing, where we are showing the same application, which is microservice 1 to microservice 4. And in this case, we are saying that the microservice 1, microservice 2 may be required for better user experience and also for bandwidth, other reasons. But whereas microservice 3, microservice 4 may be backend, or maybe some kind of a not so frequent operations might need to happen. So those can be there in central place. So in this picture, you see that there are edge 1 to edge n, and microservice 1 and microservice 2 are deployed across multiple edges, whereas the microservice 3, microservice 4 are deployed in some cloud locations, right? And then if you look at the bottom of the picture, you see a lot of users. So there are multiple geographically distributed users, and each geography users will talk to the corresponding nearby edge applications, and they get the best user experience, right? So the point is that in the distributed edge computing, okay, there are three main characteristics we believe are required. One is these apps need to be deployed on demand, because that's one major differentiation from the cloud. In the cloud, typically people just bring up applications once and they run forever, right? But in the edges, because there are so many edges, and you really don't want to bring up your apps there unless it is required, unless you have users in that edge, right? And it has to be on demand. So that is one big difference between cloud computing and edge computing. And second big difference is that it's geo-distributed, because you have geographically distributed population, then that means you also require these apps to be distributed across multiple locations. So that is one thing different from cloud computing. And the third one is that it's very critical for us for any application, right? The configuration, has to be dynamic, and it has to be application centric. When I say configuration of infrastructure, whether it's networking, load balancers, your NAT devices, security, service meshes, okay, all those things, configuration has to happen based on application deployment, right? Like again, if you look at the cloud, people bring up application and then they configure, a load balancer, security policies statically, because they are going to be staying there forever. But whereas in edge, we are saying that apps need to come dynamically. That means even the configuration of those infrastructure networking components, as I said, service mesh, load balancer, certificates, all that stuff need to be configured dynamically as and when apps are deployed. And when apps are basically terminated, then you also need to basically remove the configuration, right? That is what we call app-centric infrastructure configuration. These three are very critical for distributed computing to be successful. So with that, let me give some examples, right? Well, let me take 5G use case, right? In the 5G, there are so many CNFs. There are 5G core CNFs. You have this UPF, AMF, SMF, PCF, and many more. These are all containerized network functions that are required for a 5G core. And in 5G RAN, you have functions like CUUP, CUCP, DU, things of that nature, right? And all those functions don't get deployed on one single location, right? Like for example, DU, this is required almost for maybe for set of towers, right? So and this need to be there near the towers, almost near the towers, right? And then whereas some of the other network functions can be there little bit into the network, right? Like CUUP, CUCP. And whereas in the 5G core can be even more into the network, like AMF, SMF, UPF, as seen it here. So what you see in the 5G use case is that you have different types of edges. One is near cell tower edges, central office data center edges, local data center edges, regional data center edges. They are basically different places into the network, right? And then at each type of edge, you have a large number of edge locations. Like there is a lot of cell towers, so you require so many cell tower edge computing locations. Okay. So as you see it here, when somebody wants to deploy 5G, right, from an operator perspective, really they need to deploy these set of 5G RAN functions, 5G core functions across multiple types of edges, and within each type of edge, multiple number of edges. So the complexity of this is very, very high, right? One is deployment, right? Second is later you need to do a lot of life cycle management operations. Like what happens if vendor releases a new software? So you have to go and patch multiple your application across multiple edge locations, right? And what happens if something is not working? Somebody has to monitor all these things dynamically. So when you have these tens of thousands of edge locations, okay, this becomes very complex if you just do manual operations as we are doing today in 4G, right? So that's one important aspect of, that's where service architects are important. And same is the case with another use case, SASE use case. SASE is meant for securing traffic, that is securing endpoints when they are talking to internet, right? And you have Zscalers and many companies actually providing the SASE functionality today in set of POP locations, right? And typically one would have SD-WAN kind of a branch of these routers, UCP routers in different enterprise offices. And in the POP locations, they tend to deploy on enterprise basis, they deploy set of security functions, right? And again, you are talking about if a company like Zscaler or anybody, let's say if they have X number of enterprises and each enterprise has, let's say, Y number of offices, right? So that means the system has to deploy X multiplied by Y number of times some applications across multiple UCP locations, right? And also so many security functions in network edges. Again, this requires complex. This is a complex, and hence you require service orchestrators. And on top of it, some of these 5G guys and SASE providers, they also want to provide what we call edge computing, right? That's where you see apps in both 5G use case and SASE use case boxes. You see something called apps for each tenant, right? They not only provide this private connectivity or security in case of SASE, but also they want to provide edge computing because they already have real estate, they have the infrastructure. Why not provide edge computing for their customers? So that makes it even more complex if you think about it, right? So yeah, again, this complexity can be simplified if you have some kind of a service orchestrator. So if you look at across these use cases, what we are saying is that there are a large number of sites, right? The computing needs to happen across multiple sites, which we call Mech. Then there could be multiple tenants, right? And then and these tenants bring up applications and provider brings CNFs. So they have to coexist together. And there could be multiple types of workloads. Everything you cannot imagine that people move to containers. There would continue to be VMs, right? So one thing to think about is that any system has to support multiple workload types. Okay, and one good thing that is happening in the industry, Kubernetes is becoming a choice of workload orchestrator today in each edge location. Okay, and every provider, actually exposes the same API, right? Same Kubernetes API, which is very good for this automation. Today, if you look at VM-based systems, AWS has got their own APIs to bring up the VM-based workloads. GCP has their own APIs. So everybody has their own APIs in case of VMs. Okay, but that's not true in case of Kubernetes, right? That's a great thing. So it makes DevOps guys' life so simple because they have same API, even though it is being provided by multiple different cloud providers or edge providers. So again, the real message is that this multi-edge cloud computing, okay, the scale is even higher than what hyperscalers are used to, right? So telcos and MSPs who want to provide this kind of solutions require very good automation solutions. Okay, and that's basically what we are trying to do in Intel, trying to provide open source solution for service orchestrator. So let's see what. Before going into it, I give some more. Want to provide a big picture of what does when people say end-to-end edge stack, what does it involve, right, in a distributed edge environment. So if you look at the bottom of this picture, right, there are, as we discussed, there are different types of edges. Could be public cloud edges. There could be enterprise edges, there could be private edges, there are multiple type of edges, right? And almost every edge, especially when you're talking about Kubernetes environment, either they have VM-based Kubernetes clusters or bare metal Kubernetes clusters. In this picture, we are showing the leftmost one, the private edge. We are showing it's a bare metal Kubernetes. That means there are no VMs there. Okay, so any stack would have any Kubernetes cluster in each edge location, right? They would have Linux. You have to have multiple servers, and each server will be installed with some kind of Linux, right? On top of that, you install Kubernetes. Okay, then we are talking about coexistence of CNFs and containers, so VMs, VNFs, right? So there needs to be, the industry actually, or Intel is one of the big contributors to it, creating a lot of edge telco extensions on top of Kubernetes. Okay, this is all basically infrastructure, right? And once you have this infrastructure, of course, one can deploy CNFs, containers, DNFs, VMs, all that stuff. That's what the blue box is all about. Okay, if you look at the left side of those, the far left, right, you see something called infrastructure orchestrator. What does it mean, right? Again, you're talking about a large number of edge locations, in some cases, tens of thousands of edges. Okay, and you can't expect a skilled personnel to be there in every edge location to install operating system, to install Kubernetes, to install extensions, right? You want some central system that will automate all the installation of the infrastructure software. So that's the infrastructure orchestrator. That's a term which we at Intel use. Okay. Then if you see on the top, we see multi-cluster orchestrator, right? And this is the one which once all the software in the edges are ready, okay, now apps need to be deployed, right? The blue box which are showing that those are apps and network functions. And this multi-cluster orchestrator is the one which I've been talking about so far, is the one which actually orchestrates these workloads across multiple edge locations and automates the configuration of various middle networking infrastructure to connectivity to happen across these applications, right? Application instances, right? That is the multi-cluster orchestrator. And in case of telcos, the 5G, there's a 5G slicing orchestrator, which actually slices these edges for multiple tenants, for multiple tenant workloads, right? That's a slicing orchestrator. And then, 5G operators would have their own OSS and BSS for charging, billing, and all that stuff. So this is the full stack, right? In this stack, MCO project, which I'm talking about, is basically filling the role of that multi-cluster orchestrator that is actually put in the red border there, red color border, right? Okay. So yeah, that's what I said. I already said that is service orchestrator or the multi-cluster orchestrator. What way that MCO plays a role today, and then some of the edge telco extensions which Intel actually has been in the leadership role there, contributing these extensions. Okay, and that is not part of the MCO, but a lot of Intel projects are there as part of that. And then there's one more picture. One more thing which I want to show here is that MCO, of course, it can talk to Kubernetes cluster APIs directly, as shown in this arrow, right? But we also have a way to MCO also can deploy workloads via some of the central systems provided by providers, cloud providers. For example, Microsoft has got something called Microsoft Arc. So MCO can talk to Microsoft Arc to place the workloads on Microsoft Kubernetes clusters. And in case of Google, we talk to Anthos configurator to place the workloads on Google Kubernetes clusters, right? So that's what, and then in case of Intel, we also have a smart edge controller to deploy apps on smart edge based edge locations. So the point I'm trying to make is that MCO is designed to work with clusters that enterprise clusters where there is no special special central system, and also it can talk to some of the popular today, at least Arc and Anthos is what we are basically focusing on. It can talk to, sorry about that. Yeah, it can talk to those provider specific central systems to play, deploy the workloads. Okay. And then I just wanted to show one thing here, the big arrow here, that is Acrino blueprint. Acrino is part of Linux Foundation Edge project. There we have some of the blueprints called ICM, Integrated Cloud Native Blueprints. It is showcasing some use cases, for example, network slicing use case, 5G use case, by putting together all these things, right, as a blueprint, right? So at the end of the day, what we are saying is that, things are disaggregated so much now. There are so many components, Linux, Kubernetes, and extensions, and MPO. They all need to be put together as a solution, right? Of course, you can depend on some vendors, but in the open source, Acrino is basically taking up the role of putting various open-ended components together to show end-to-end solution, right? And you may want to check that out if you want to build end-to-end solution yourselves. Okay. So let me skip this. So we talked about service orchestrator, right? And MPO plays a role. But before talking about MPO capabilities, let's understand what are the requirements or what are the expectations from the service orchestrator, right? And this picture showing the 5G as I described before, and the service orchestrator will be installed in some central location somewhere, could be in public cloud Kubernetes system, right? And this is the one. This is the basically expectation is that it provides a way for administrators, one-click deployment of complex applications and network services across multiple Kubernetes clusters. Like as I said, these are all 5G functions. All 5G functions with one single click should be deployed across tens of thousands of edge locations. And in this case, we're also talking about, DUs to be put into cell tower edges, whereas CUP, CUCP to be there in CODC. So there's a placement definitions have to be made, intents, and once the placement intents are created in the service orchestrator, the expectation is that with one click, service orchestrator will take care of deploying different pieces of 5G across multiple edge locations. Right? So that's the expectation. And second expectation is that comprehensive status monitoring. Right? You deploy this complex application, different network functions, different microservices at different locations, but you have to continue to monitor whether everything working okay or everything is up and running. Okay, so so again, the expectation that the service orchestrator does that and provide any status reports once in a while to the users, right? And then the other expectation is that service orchestrator should orchestrate CNFs, the containerized network functions, containerized applications, VNFs, VMs, and tomorrow even WASM plugins, P4 programs, functional service functions. That's expectation. Eventually, one service orchestrator should be able to deploy any type of workload across multiple edges. And the fourth one is this self-service portal. Okay, that is very, very key, right? Like as a provider, you may deploy 5G network functions, right? But you also want to provide a way for your customers to deploy their applications, okay, without coming to you, right? That means you should provide self-service portal for those tenants, your customers, to deploy, to onboard their applications and deploy their applications across multiple edge locations. So that is, in my view, that's one of the critical things one would expect from service orchestrator. Okay, and then of course you need to have analytics platform for data operations. if you want to check historically what is happening across multiple edge locations and use that history to predict something later on, you need to have, we believe that service orchestration should have analytics platform and then allow people to bring their own training and inferencing apps on top of this analytics platform, which actually figure out what to do and then have a closed loop controls to change the behavior, right? So that's another thing which we believe orchestrators are expected to support. And the last one, I think I already talked about, that app-centric infrastructure configuration based on the type of app and how they need to communicate with each other. We may have to automate service meshes and SD-WANs and L2 L3 switches. Again, the expectation is that service orchestra will do that kind of a automation of infrastructure components to allow the connectivity to happen across application components, right? Okay, with that big picture, let's see one by one, right? Let me see what time it is. Okay, we have some 20 more minutes. One of the first and foremost thing, right? Somebody has to let the service orchestrator know what are the edge locations, right? You could have a lot of enterprise edge locations, you could have cloud locations, you have different types of network edges. Okay, so service orchestrator is expected to provide a way for administrator to register what Kubernetes clusters or what edge locations that this service orchestra is supposed to be deploying the workloads on, right? That's a cluster provision. And then there's one more thing which people expect, that is, when you have a large number of edges, right? Like in this case, we are saying cell tower edges could be tens of thousands, and where you need to deploy DO, right? And when you provide a placement intents, if you say that you want DO to be deployed in the thousands, and then if you expect the configuration of all the thousands, that's going to be problematic. So people expect some kind of labeling. So label the clusters, and when you are deploying application, you can say that I want to deploy this component of my application in all edges that are labeled with cell tower, right? So to make it easy, the labeling can be used. So service orchestra is expected to provide ability for administrator to label the clusters, not only register but also label them. Okay, and then sometimes you have a cluster specific configuration. Every time you add a cluster, maybe you want to automate some not application specific configuration, but cluster specific configuration. Like for example, Istio CA provisioning. Okay, maybe you may want to prepare some virtual networks, provider networks. Okay, all the stuff also are expected to be taken care of by service orchestrator. And the third thing is, other one is the tenant, right? We said, tenant, you need to provide self-service portal for tenants to onboard their own applications and then deploy the applications across multiple locations. That means, before the tenants can do that, somebody has to create those tenants, right? The tenant provisioning has to happen. So that's one capability is expected in the service orchestra. And then we also said that, same edge location can be used by multiple tenants, right? And you want to provide some isolation. Kubernetes already provides very good isolation using namespaces. But when you want namespace to be created across multiple edge locations, again, you need some kind of automation. And that's where this logical cluster provisioning is expected to be taken care of by service orchestrator, right? These are the preparation is what we call them. And these things will happen by the service providers administrators. Of course, mostly they're done in the initially, but of course, as and when you get more clusters, more tenants, you also have a way to dynamically add more clusters and more tenants and more logical clusters. So that's an expectation. Okay, now that you provision, now tenants can come and onboard their application services, right? In case of 5G, they can onboard 5G RAN and 5G core into the system, right? Then you can define placement policies, right? The expectation is to define placement policies. as I said, in this case, we are saying that once 5G service onboarded, within 5G service, we have so many network functions, and you can define this network function has to be in the cell tower edges. And these two network functions need to be there in the CODC. That is what we are calling defined placement policies. So that's one expectation in the service orchestrator. And then sometimes what happens is that you define the policies to place the workload, but sometimes you may have choice of multiple edges, right? For example, let's say I want to place my workload in New York, but New York there may be edges coming from maybe multiple providers. So I want to choose which provider to place my workload on. But how do I choose, right? That is where the service orchestrator is expecting people to define some placement constraints. Okay, I can say that I want the system to choose a edge location that is actually cheaper, or I can say that I want to choose a edge location that has GPU, right? So that's something expected by the service orchestrator. Hey, Prakash, you are able to hear me, right?
I'm able to hear you, no problem. Absolutely no problem. Continue. You're continuing.
And the other set of features expected from service orchestrator is workload customization, right? So that is, see, you are talking about large number of edges, okay? Sometimes, let's say in the CODC, for example, let's say local DC example, let's say you have UPF, okay? But all the local DC edges may not be same. Some edges may be very powerful, maybe they have large number of servers, and some edges may have a very small number of servers, right? So, but you are placing the UPF on all type of edges here, all edges in this type. But you want to customize, like if you can say that if I'm deploying UPF on this edge, one of the edge locations here, maybe I want to dedicate 16 cores, maybe 2 gigabyte of memory. Whereas if I'm bringing on this edge location, I only want to put UPF with the 2 cores. Okay, so this is one example. So there is based on the type of edge it is being workload is being deployed on, you may want to tune the configuration accordingly. Okay, again, the expectation is that service orchestrator provides a mechanism to create this intent, saying that this is my intent, UPF on these type of edges, I want it to be dedicated with the 16 cores. So once they provide the intent, then again at the end of later on when they instantiate, you should honor all these placement intents, your customization intents, and then apply accordingly. So that is one important feature is expected by service orchestrators. And I talked about already, automation of connectivity and security is very important. If, for example, if you have a client microservice and server microservice, right? And you want only that server microservice to accept connections from the right client microservices, right? So you can define, service orchestration provide a mechanism to define that server client kind of relationship, and define what kind of connectivity is required, and define what kind of security is required, and what kind of policies are required, right? Once you define that, yeah, you expect service orchestrator to honor those intents, and then create the policies in either in the service mesh or SD-WAN and firewalls and things of that nature. So that's also one of the expectations from the service orchestrator. So once you do all that stuff, as I said, once you onboard the workload, and once you define the placement intents and the placement constraints, and once you define the customizations and connectivity intents, you provide one click called instantiate, and service orchestrator is expected to honor all those intents, placement intents and customization intents, and then place workloads appropriately, accordingly across multiple locations. Right. So once you do that, as I said, somebody has to, after that, somebody has to continue to monitor the application. That's one feature that is expected by service orchestrator. And then other feature expected is that day two configuration, right? You deployed everything, but you want to configure those CNFs, right? So that is also very much required. Like for example, let's say if you have private 5G, subscribers need to be added, right? How do you add the subscribers? It's not that you know all the subscribers on the day one, right? There could be more subscribers coming into coming into your system. Like for example, the private 5G, maybe there are more employees are joining, or some employees are resigning. So you need to have a mechanism to auto incrementally add subscribers or delete subscribers in the 5G example. Like that, you have multiple examples for configuring CNFs dynamically. So that's one more thing expected. Again, why it is important for service orchestrator? Like when in case of private 5G, when employee joins, you need to add the subscriber across multiple private 5G instances of that particular enterprise. So that means you require this automation across multiple edge locations. Hence, the service orchestrator plays a role there. Okay, now we talked about service orchestrator roles and responsibilities. And what we are saying in this slide is that the MPO is one of the service orchestrators, which is a LFN project. Intel contributed that to LFN in October last year, October 2021. It's an open governance, and it's being used by many people, which I'm going to talk about it later. But this picture shows that MPO is an implementation of service orchestrator addressing majority of the requirements, which I talked about. It's also extensible architecture. Okay, it allows new automation requirements. Okay, in the sense that today, for example, we automate Istio Envoy based service mesh, right? Which is very popular. Maybe 40 to 50% of Kubernetes microservice solutions use Istio Envoy for layer 7 communication. But the Istio Envoy is not the only one. There are other service mesh technologies like Linkerd and Puma and many more, right? We are not from LFN MPO team perspective. We may not be doing orchestration of this or automation of these other service meshes. But what we are trying to say is that it is extensible architecture, so people can add more microservices, more automation microservices to the system at the right lifecycle management hooks. Okay, and then the MPO has the ability to call those external microservices for various lifecycle management operations. Okay, so that's what we call extensible there. So if you look at the architectural, very high level block diagram perspective, all the thick blue colored ones are basically constitute MPO. Right? There is a cluster registration controller, whether it is a distributed application scheduler, and then we have some placement constraint controllers like hardware platform aware controller. And I talked about it, right? Like if you have a choice of deploying your application across, let's say 3-4 edge clusters, which one to choose, right? And one of the critical things which we understood is that some of these applications may be using some GPU, right? Some particular vendor's GPU, and then in those cases, you can create a constraint saying that I want these apps to be deployed in edge location that has so and so GPU. So that's this hardware platform aware controller basically provides that option of specifying some constraints. And the traffic connectivity and security controller, I think I already talked multiple times. This is how do you automate service mesh, NAT, and everything. Okay, and then if you look at the resource synchronizer, right, that is what is synchronizes the all the intents. It converts into Kubernetes standard resource and custom resources, and the resource synchronizer synchronizes those things across multiple edge locations, right? That is a very critical piece. So with that architecture, let me move on to what we have done so far. In the 2021, after we open sourced into LFN, we made one release 21.12. It has all these features that are shown in this slide, right? And then in 2022, of course, our intention is to improve the quality levels, which is pretty good today. But still, at the end of the day, we could, as a LFN community, we could test with maybe 10, 20 clusters. But in the real life, there are thousands of clusters. That scalability testing becomes very, very important. So we are finding ways to simulate so many clusters, without having so many missions also. And then at least showcase that, there are no, at least basically identify if there are any problems in MCO. So that we are continue to do that as a community. And there are some features which we are adding in 2022, right? And we already added something called temporal workflow support. It's this requirement came from multiple MCO users. They say that, when we are deploying applications, of course, there are Kubernetes-based CNFs can be configured, but they have some more additional ones to be configured, which are not Kubernetes-based. Right? It could be netconf-based, or it could be RESTful API. In those cases, the question they asked is that how do we basically automate those kinds of things which are not Kubernetes based, but at the same time, those need to be configured in the life cycle of these applications, right? That's why we provide this workflow support, so they can create workflows which actually go and configure their other non-Kubernetes specific items. So that's something which we got we get one MR, a merge request, just 2 days back, and that's going to be made available in 22.03, which is a March release. Okay. Yeah, we're working on Istio CA certificate automation now, and then we're also working on dynamic slicing orchestration, which is required. Network slicing. Slicing is very important, we believe. And then latency aware placement. There's something called 5GFF, which is being led by Verizon and some of the telco operators. So they have a service called EDS, Edge Discovery Service, and basically that service provides a way to, it will tell you if you give your longitude, latitude information of users, and then it will tell you what are the, and then latency, your minimum latency, maximum latency information. Then they provide right edge locations that satisfy that latency with respect to the geographic users given as a longitude, latitude, right? So one of the reference we got is that, can we use those APIs to identify the edge locations to place the workloads on? So we are creating the one placement constraint controller based on this 5GF. Okay, and the Mech Support is very important. Like edge computing is, 5G means basically people equate that with edge computing. Okay, that is, you have a distributed UPF, and if you place the workload at the near to the UPF, you get the best latency, right? Again, that requires some kind of automation. So that's one more thing which we started to work on. So let me not go through everyone, but this is the plan for 2022. The MCO integrations perspective, it's becoming quite popular now. There's a company called Arna. They basically create a commercial solution called AMCOP, which is based on MCO, right? And they also provide commercial support for MCO itself. If somebody wants to use MCO from the open source as is, they provide commercial support. Okay, and there's another company called CalSoft. They also announced that they would be providing commercial support for MCO. And a lot of academic projects are using. And then based on some of the bug reports which we see from in MCO community, it appears that at least in the recent past, around 4 companies they are actually using MCO they want to use MCO in the real deployments. Right? So, and this picture shows a company in Singapore. They are using MCO in the private 5G to deploy private 5G. Okay, so this is the MCO here. All these things are already available except for this private 5G configurator. That company is doing this. Okay, and these are they have these enterprises having big site, big offices, medium offices, small offices, and based the type of office they want to deploy, different components. Like in the big offices, they want to deploy 5G core and Mech SASE, all that stuff in the same thing. Um, in case of small offices, they just want to deploy RAN, and whereas 5GC in some other cloud location. So the point is that there are different variations of your 5G components based the type of edge it is. And of course, MCO has that capability, and they are doing this stuff as we speak. So there's some more examples. MCO is being used by Equinix, and then there is one telco is using MCO for their 5G deployments. Okay, with that, let me stop here. There are some set of slides I have on the slicing work which we are doing. Maybe I'll just briefly talk through them, but I won't go deep into it.
Sure, go ahead.
Yeah. So in our belief, network slicing is today there is no slice. Like there is only people are looking at just the connectivity to end users. Okay, end users to internet, just like 4G, right? For that there is no slicing required. I think that's what's happening today. And then we believe in next, people started to think about providing Mech support in the 5G sites, right? And that's what we call phase 1.5, right? Then we believe that operators are going to support what we call static slices, right? Static slices are, for example, URLLC is required for robotics and autonomous vehicles kind of thing. We may require URLLC, EMBB slice, okay, which is the broadband slice, which is what is there today even in 4G, and massive MMTC, like it's for IoT kind of deployments, a large number of IoT devices. Okay, these are all static slices we believe, one for each type of use case is going to provide by operators. But eventually, okay, our belief is that by 2025 is what we believe at this time. Of course, operators will provide some static slices, as we said before, and they're also going to provide support for other companies to bring their own slices, right? That's what we call dynamic slices. Okay, for this to happen, you require some good slicing orchestration. And one of our intent is that we started this activity separately now, but eventually we believe that the service orchestrators would support slicing orchestration also. So keep watching out our MCO announcements. So we'll provide slicing orchestration soon. Okay, so let me not go into this. Yeah, with that, I want to thank everybody. But as students and because you are part of universities, MCO is open source project, and you join, it's openly available in the project-mco.io. Okay, you download the code, understand yourself, and then try it out, and then you can help us in many ways, right? One is you can raise bug reports if you have challenges, and you can even fix the bugs, like by becoming a contributor. And very easy, it is open, it's open governance. There are a set of committers who would review your changes and then merge them into the main line, right? So the great way to start is to download, try it out, and then even contribute in the documentation, contribute in bug fixes, and contribute by creating new modules. So hopefully this project is helpful in getting started on MCO. So hopefully we'll see some contributors in MCO. Thank you.
Excellent. I think you covered very wide range, and I'm amazed at the progress you have made since ONAP Acrino blueprint. where and all the so many splintered uh, what you call blueprints are there. It was hard to figure out where is it going. Now you have brought in MCO everything together, including the RAN, ORAN on this side and enterprise on the other side. So what I see, if I can ask you a couple of questions.
Yeah, yeah, sure.
So one of the things that came to my mind is that when you have a service orchestrator, of course you said cluster orchestrator, then from cluster you move to service orchestrator, and then put other orchestrator in between from like what is it, uh, Google's Anthos, and
Uh,
then we can also put some like Magma from 5G from Facebook. So what I see is. It is mother of all orchestrators, it appears to me. And
yeah.
and in that case, what happens if you have a policy which is already running, like open policy agent, OPA or something is being used by one of those? How do you accommodate policies in this? Because
Yeah, yeah. It's a good point, right? I mean, see, OPA is at another day
mm,
uh, takes input in a Kubernetes API. I mean, you can configure using Kubernetes APIs, right?
mm,
Anything that is configured using Kubernetes API,
mm,
you could use MCO.
I see.
Okay. So that is the beauty of it, right? So you OPA runs in each edge or each Kubernetes cluster, right?
Mm,
So you could take MCO to automate that aspect of it.
mm,
So yeah, I mean that's the beauty of it. That's the beauty of Kubernetes today. They have a common API with the different standard and custom resources, right? And
mm,
as long as their Kubernetes resources is very easy to use MCO as is. But if you have something else, some other way to configure, that's where we brought up this temporal stuff, where you could automate that configuration also. Yeah, as you said, MCO is a kind of a encompassing multiple types of orchestrators together as a single entity. So as a single, that's what we call it as a. I mean, I think somebody call it as a universal control plane, right?
okay, okay, it's interesting. So the part why I ask this is because if I am running some let's say workflow engine and with all the policies, and that is under radio is different, under what do you call, the core is different, application is different, and eventually we need to also make sure that there is a billing OSS BSS integration is there. Of course ONAP is there, I hope you're using that. So it's a challenge for a deployer, and especially if a research folks takes this and say, hey, I want to just run and I want to do integrate, let's say Magma 5G core, which has another orchestrator, and then along with that there is some network.
No, Magma. One thing is that it's a complementary.
Mm,
Magma, there are two components today, right?
mm,
Magma 5G core, which is like a network function,
correct.
and the other one is Magma orchestrator, which is actually the term orchestrator is a little bit confusing, but it's really
Exactly.
a configurator. Magma is a configurator.
Okay.
So, and I talked about Day2 configuration, right? It's a Day2 configurator.
Hmm.
That's it configures those 5G core network functions.
Hmm.
So, so actually, Arna Networks guys have integrated Magma,
Hmm.
rather orchestrated Magma using the MCO.
Okay. Okay.
Yeah.
So I will need to get into details, but I just am posing questions on behalf of the researchers to see that you have got ample of scope here to innovate. Not
Yep.
only the policy side of it, the real time side of it, then the integration side of it, and all comes together into this. And there are real life customers, which is very, very key for any success. And I believe if you have service provider MSPs as well as the uh, what do you call, the communication service providers or the telco service providers, if all of them latch on to this, then we have a real great opportunity for this to grow. And I would like to see that we all support Srini and his efforts. he has been one of the bright thinkers in this, and he has tried several things. And it is important. Do not worry, fail. You can fail, but fail fast so that you can move on to the next. And I have seen the growth of what Srini has produced over a lot of open source projects. And I'm really thrilled to acknowledge that. I salute him for what he has done. And I hope he gets more and more success with our support. All of the research folks, I would like you to ensure that you participate in MCO and give him the necessary ability to harmonize in the industry, which is very hard with different players making revenue in different spaces to be able to come together to collaborate. So please do
Thank you,
your
Prakash.
best to support Srini. And with that, I think I will close this session. Srini, you have the last word. Go ahead.
Yeah, I really want, I mean, it is easy to use, certainly. And I hope, I know that Kubernetes deployments are complex, and MPO is simplifying it quite a bit. Okay. And I'm sure you would find a lot of value. And any innovation you intend to do on Kubernetes or distributed edges, I'm sure MCO would be helpful for you to jumpstart your research. So, and as part of your research, please do contribute to MCO. I'm sure it is it doesn't work as you expect in some use cases. So we really appreciate your trying it out and your contributions with respect to any type of contribution. As I said, documentation or generating bug fixes, bug reports, and also fixing bugs. So with that, thank you for this opportunity, Prakash and Vipin. Thank you all.
Thanks. And with that, we'll close the session and look forward to again once more in the next 6 months to a year to come back and review this again. Okay. Thanks a lot. Appreciate it.
Thank you.
I'll
Thank
stop.
you.